Okay, so in this video, we are going to go from absolute value equations to absolute value inequalities. So it's helpful to remember that absolute value measures a number's distance from zero. So when we have absolute value of x greater than 3, in words, what we have is what numbers are more than 3 units from zero. So absolute value of x greater than 3 wants numbers that are more than 3 units from 0. So if 0 is here, we need to go more than 3 units away from 0. So that might be at 4, that might be at 5, that might be at 3.5. It's basically everywhere from 3 onwards. But we also need to go in the other direction 3 units, more than 3 units from 0. So that could be at -4, -5, -3.5, anywhere over here on the graph. So we should be able to recognize this as the compound inequality OR. So the answers to what numbers are more than 3 units from 0 is any numbers less than -3 or any numbers greater than 3. So when I see the greater than symbol in my original problem, I like to think of greater than as great or, because we, as we can see, are going to get a graph that's an or compound inequality. Whereas if we have the absolute value of x less than 3, what we're looking for here are what numbers that are less than 3 units from 0. So if we look at a graph here, any number that is smaller than 3 is going to be less than 3 units from 0. So maybe 1, 2, a half. Anything that's below 3 on this side is going to be less than 3 units away. But same thing on the other side of 0. Anything that's at -1, -2, -2.5, anything that's above -3 is going to be less than 3 units from 0. So what we have here is that x needs to be bigger than -3, like -2 and -1, and it also needs to be less than 3. Or we could also write this as -3 less than -3 less than x less than 3. And so when I see the less than symbol, the way that I remember that I'm going to get an and compound inequality is I think less than. So great or less than to help me determine if I'm going to get an or compound inequality or an and compound inequality. So here are our steps to solving absolute value inequalities. Our steps are going to be similar to when we were doing regular equations. We always want to make sure we isolate the absolute value to one side of the inequality. Then we want to decide, is it an and compound inequality or an or? So like I showed you, the greater than symbol are great or. So if you get a greater than symbol, think great or. If you get a less than symbol, I want you to think less than. And then from there, once you decide if it's and or, you're going to make two inequalities, just like we would make two equations. The first inequality is going to be exactly the same. The second inequality will change the symbol, change the sign. And then from there, we're just going to solve and graph the two inequalities. So for example, if I had the absolute value of 2x plus 1 is greater than 7, first of all, if I look, my absolute value is already isolated. So now I need to decide if this is and or. Since it's greater than symbol, great or is my mnemonic device to remember. So my first inequality is going to remain exactly the same. 2x plus 1 is greater than 7. My second inequality is going to be 2x plus 1. Change the symbol to less than, change the sign to negative. So the second inequality, I like to say, change the symbol, change the sign. And then we're just going to solve the two inequalities that we get. So x is either greater than 3, or if I solve the next inequality, x is less than -4. So here is -4, here is 3. We're going to do open circles on both because it's just greater than or less than. And we get an or shaped graph because our compound inequality was or. All right, for the next one, we ask ourselves, is the absolute value isolated? And it is. It's on one side of the inequality symbol. So I'm going to jump right into solving by putting and in between the two inequalities because it's less than. So I make my two inequalities. The first one is exactly the same. X plus 8 is less than 10. The second inequality, I'm going to change the symbol, change the sign, so it becomes greater than -10. And then I'm going to solve each of them. So I get x has to be less than 2, and x needs to be greater than -18. So I've got -18, and I've got 2. I've got open circles on both, and it's everything in between. It's a sandwich inequality. And which. All right, so for this one, the absolute value is not isolated. So I need to get the absolute value symbol on its own. So I'm trying to isolate this. So what I need to do first is I need to get rid of the +6 by subtracting 6 from both sides. Then I'm going to have to divide both sides by -2. And what I cannot forget is the rule that says if you divide by a negative, you have to flip the inequality symbol. So this actually turns into greater than 9. So now that it's isolated, I can go to solving. Since it's the greater than symbol, I think great or. So you always need to write what your compound inequality is, if it's and or. So I'm going to write or, and I'm going to make my two inequalities. First one is exactly the same. Second one, I'm going to change the symbol, change the sign, so it becomes less than -9. And then I just solve each one separately. So x is greater than 14, or x is less than -4. And again, these are open circles because there's no line underneath the inequality symbol, so we don't shade in the circles. And as always, we have a couple special cases here. So the first special case is that an absolute value inequality could have all real numbers as its solution. That would occur if the statement was always true. So the way we're going to get an always true statement is if we have an absolute value. So if the absolute value of x is greater than -3. Because if you think about it, what kind of number is an absolute value? An absolute value is positive. So essentially what this statement's saying is that a positive number is greater than a negative number, which is always true. So since this is a true statement, it's all real numbers. So when you isolate the absolute value, if there's a negative on the right-hand side and it's greater than, it's going to be all real numbers. If when you isolate the absolute value and it's less than a negative number, well, think of the same thing here. Absolute value is always positive, right? So if I get a positive number, can it ever be less than a negative number? No. So this is going to have no solutions. So what needs to happen with these types of problems is if your brain sees a negative number on the other side of an inequality, you need to stop and think, is this always true? Is it greater than the negative? Or is it always false? Is it less than the negative? And that will help you decide if it's all real numbers or no solution. So for example, if I had -3 times the absolute value of x plus 6 minus 4 is less than 10, if I isolate the absolute value, so I've got to get the absolute value alone. So I like to put it in a box to help me visualize the isolation process. Let me make sure that I don't get the negative sign in there. So I'm going to get rid of the -4 first by adding 4 to both sides. And so I get -3 times the absolute value of x plus 6 is less than 14. If I divide by -3, what's our rule when we divide by a negative? We have to flip the inequality symbol. So I get the absolute value of x plus 6 is greater than -14 thirds, because I can't simplify that fraction. So my brain sees that we have the absolute value and a negative number on the other side. So I need to think, is this true or false? Well, absolute value is positive. Is a positive greater than a negative? Yes, always. So this is an all real numbers answer.